How many VAs would you calculate for a single family dwelling that has the following appliances? 4200 VA main water heater, a 3500 VA additional water heater for the basement, a 1000 VA disposal, and an 1100 VA dishwasher. 220.82 Part B3 states that we use the nameplate rating, so the 4 or more 75% rule does not apply using the optional method. You're just going to total them all together, 9800 VAs, and you're going to select B. How many VAs would you calculate for a single-family dwelling in Dallas, Texas that has the following appliances? A 4200 VA main water heater, a 3500 VA additional water heater for the basement, a 1000 VA disposal, and an 1100 VA dishwasher. If we've committed to memory the 4 or more appliance rule 75% demand factor, then we do not have to repeat the index process. If we've forgotten, we could just pick through the question and repeat the keyword process. Okay, so we just take all of our appliances and total them together. Then we apply our demand factor. Remember, if there are 4 or more appliances that are fixed in place on a service or feeder, you can apply the 75% rule, which allows you to do a 75% demand factor on your appliances. So we take our total, multiply it by 0.75. That is going to give us 7,350. And we're going to select C. I want to note that test takers will always put an answer in that is missing one of the steps. So if you get in a hurry, you can get caught by their trap. If you notice, B is 9800 as if you missed one of the steps, and the test takers know that. So always be careful, remember all your rules, and you'll do well. What is the total VA demand you would calculate for an 1100 square foot home with the following loads using the optional method? Okay, so we have all of our loads here, heating and cooling, range dryer, so on and so forth. Okay guys, step 1. We are always going to calculate our general square foot in our small appliance laundry circuit VAs. So we do our general. That is going to give us 1100 multiplied by 3. That is going to give us 3300 square foot VAs. Then we add the 4500 small appliance and laundry circuit, and that's going to give us 7800 total VAs. Step 2, we're going to do our fixed appliances. In this case, we have more. 220.82B3 states use the nameplate rating, add them together. That's going to give us 6800 VAs. Now let's calculate the dryer load. 5200 VAs. We're going to use the nameplate rating when doing the optional method. Step 4, now we're going to do the range load, 13,000 VAs, and we're going to use the nameplate rating. Now we just add them together. That is going to give us 32,800. Now we check for demand factors. And in 220.82b, it states that we should calculate the first 10,000 at 100% and then 40% of the remaining VAs. Step 1, take your total minus 10,000. That's going to give you 22,800. Step 2, you're going to multiply that by the 40% demand factor, which is 0.40. That is going to give you 9,120. Then simply add them back together. 19,120 VAs for the general circuits of this home. Step 5, you do the larger of the heating and cooling. 5 kW and a 22 amp at 240. That is going to give us that the cooling is larger in this case at 5,280 VAs. Select the larger. going to give us 24,400 VAs after we add the both together. And we're going to select B. What size overload protection would you select for a 7.5 horsepower 208 AC 3-phase motor terminating to 60° C terminals with a nameplate FLA of 22 amps? Okay, so we always size normal overload protection by the nameplate current rating, or FLA, not the FLC that is listed in 430.248 through 430.250. And we always use the next size down for normal overload questions. So let's look at our question again. I do not see anything about service factors or temperature rise, so this is going to fall under all other motors. Now we just multiply. 22 multiplied by 1.15, that is going to equal 25.3. Let's head over to 240.6a using our OCPD tab and select our protective device. We select the next size down, and we're going to select a 25. So pretty simple, just follow the rules and let's keep practicing. What size overload and short circuit ground fault protection would you select for a 5 horsepower 230 volt AC single phase motor terminating to 60° C terminals with a nameplate FLA rating of 23 using fuses for the overload and the inverse time breaker for the short circuit ground fault protection? So there's a lot going on here. You can do it, just take it step by step. First, size your overload protection because it's already given you the information. We use our nameplate rating. It's just a regular motor. There was no temperature rise and there was no service factor listed, so you just multiply it by 115%. So you take 23 multiplied by 1.15. That is going to give us 26.45. Now we head over to 240.6a, select the next size down, and that's going to be a 25 amp overload protective device. Now let's size our short circuit ground fault protection. What is our FLC? We need to head to our FLC tables. So we head to 430.248 for single phase. We're going to use the table that is on page 321. We're going to select the respective horsepower, which is 5. We're going to select 230 volts, and we find that our motor FLC is 28 amps. Okay, now let's head to table 430.52 because that is going to be where we find our multiplier. It said that we're going to be using an inverse time breaker, and we're on single phase, so our multiplier is 250%. Okay, so 28 multiplied by 2.50 equals 70. You head to 240.6a, and we're going to select 25 amp overload with 70 amp short circuit ground fault protection, and that's going to protect you from short circuits and ground fault protections. If you're just catching this video and you did not watch last week's video, we go over how to calculate short circuit ground fault protection from scratch. So thank you. What is the voltage drop of a 200 amp circuit using 4-aught copper conductors that is 225 foot long on a 120 240 volt system? Okay, so here's our formula. First, we plug in everything we already know. 2 multiplied by 12.9, which is our constant for copper, multiplied by 200 amps, multiplied by 225 feet. Now we need to divide that by the wire C-mills. Now we head to find our C-mills, we head to Chapter 9, Table 8. What are the C-mills for 4-aught? Why don't you pause the video now and find that? And it is 211,600. Now we just divide. So we take 2 multiplied by 12.9 multiplied by 200 multiplied by 225, and we divide that by 211,600. And we are going to get B. How many cubic inches would you calculate for 5 number 12 AWG wires and 3 number 10 wires for box fill calculation purposes? So we're going to head to table 314.16b. I'll give you a little tip. There is a box sizing tab on your codebook. So just close your codebook, use your box sizing tab, and flip open, and you'll flip straight into the area of 314.16b. So we find when we look at this table that we have number 12 conductors, and they have a cubic inch volume of 2.25. When we look at number 10, they have a cubic inch volume of 2.50. So you just do the math. In your question, it said that you had 5 number 12s. So you take 5, multiply it by the number 12 cubic inch value, and that's going to give you 11.25. Then you take 3, your question stated you had 3 number 10s, multiply it by its cubic inch value, and that's going to give you 7.5. You have 18.75 cubic inches total, and you're going to select B. So every conductor has a cubic inch volume. Your outlet box is only going to allow so many cubic inches into the box. So you have to do the math and figure out how many of those conductors you can fit in there. We're getting ready to learn that it gets a little more complicated than this because you have devices like switches and receptacles. You're going to have wires that pass through the box but don't terminate. So there is a prescription for all these different scenarios, and you're likely going to be tested on some of these different scenarios. So let's learn about it now. Plus, this is really just a great thing to know for the field, whether you're an installer or an inspector. Before we do this one, I want you to close your code book. We're going to do this question from scratch. How many number 14 conductors can you fit into a 4 by 1.5 square box? So we're going to use our box sizing tab. We're going to flip straight to table 314.16a. We're going to find out what type of box we're working with, and then we're going to slide over to our type conductor. So we need to go to square boxes, and we need to find a 4 by 1.5 inch square. It's in the second column in the middle. And we're going to slide over to our conductor, which is a 14. and that's listed across the top. Then we're going to slide down to our box, and it looks like you can fit 10. So we're going to select D. Great job. Okay, so we have 6, 3, and 9 as our resistors. Okay, so what is the total resistance of this parallel circuit? I want to note out right away that we have 4 options here in our question. The answer is always going to be smaller than the smallest resistor in the circuit. So if you're in your testing center and you get a question like this, remember, we're just covering basic questions that you might meet. This is not an all-inclusive DC fundamentals. This is just teaching you some basics, okay? That would be a whole nother 10-week course. But if you look at this, we can tell right away that A and B are not going to be correct because the total resistance of a parallel circuit is going to end up being smaller than the smallest resistor. So that's an easy way to figure that out. So now if you had to guess and you forgot the steps, you had a 50-50 shot. Just select C or D if you couldn't remember, and you got a 50-50 shot of getting the question right when you're in the test. Remember, always mark an answer on your test as correct. Even if you're just taking a total guess, you can mark it to come back later, but always put an answer because if you run out of time, you got a 1 in 4 shot of getting it right. Okay, so we take our 1 divided by 6 plus 1 divided by 3 plus 1 divided by 9. Go ahead and do that on your calculator now. Pause the video if you need to. If you took the time and worked that out, it is going to give you 0.611111. Okay, so I have found when you're doing this, and I'll give you this tip in a minute, just hang loose. But we cannot stop there. We must then take the reciprocal of that number. So we must then divide 1 by that number. So we take 1 and divide it by 0.611111. And this is where this tip comes in. So you take 1 and divide it by the number that you came up with. So in this case, it's 0.6111. And the question is how many of those ones do you put? What you do is go ahead and put the 1 divided by whatever the number is, and then type it in as many times until you get an answer that's close to one of your choices in your question. So in this case, we keep typing it in until we get 1.636, which is going to allow us to round up, and that's going to give us 1.64. I'll point this out that the testing center is not going to put them that close that if you did not round up or down, you're going to get the answer wrong. If you notice in our question, D is one whole number larger than that. So you're going to be okay there. So just type it in until you feel comfortable with one of the answers that's represented. And then we rounded up and we selected C. Let's do an appliance load calculation. When sizing a service or feeder for blank or more fixed appliances, you can apply the fixed appliance 75% rule. Since we know it's a calculation question, what should we do? Flip to our Calculations tab on our codebook. You can save the index process because you know that it's about a calculation. Using our keyword process now, when we feel like we're in the right article, what should we do now? We should look at the black bold headings. So what you're going to do is look at the black bold headings, but first, let's pick out a keyword from our question to look for. What's a good keyword from our question? We're looking at the black bold headings, and we're going to look for appliances. That looks like the overall theme of the question. Let's look. Here in Article 220.52, we find something about appliances, and I want you to go ahead and read that now. Pause the video if you need to. That's not what we need. But if we look right under that, anytime you read something, you quickly find out it's not what you need, you continue looking at the black bold headings looking for your keywords. Okay, so right under it, we find 220.53, and we read that it's almost word for word what we need. Go ahead and read it now. And we find that it is D4. So if there are 4 or more appliances, you can apply the 75% rule. And we're going to learn what that is now.